This is the e-learning lesson for section 4.8a, Applications of Trigonometric Functions. In this lesson, we are going to be solving a right triangle using both right triangle trigonometry and/or the Pythagorean theorem to help us find missing side lengths and missing angle measures. Don't forget SOHCAHTOA. It's a good way to remember our trigonometric ratios as we need to use them in solving a triangle. So let's look at our problem. We have right triangle ABC, and we are given angle A as 62.7 degrees. So I'm going to mark angle A as 62.7 degrees, and then side A, which is the side opposite angle A, as 8.4. Don't forget that the side opposite angle B would be called side B, and the side opposite angle C would be side C. So the first thing I know is it's easy to find angle B if I know that I have a right triangle and I know one of the acute angles, angle A, is 62.7 degrees. So angle B, which is the other missing acute angle, is going to have to be found by taking 90 degrees minus 62.7 degrees, and that is 23.7 degrees. So that's our first missing angle. We could write it in there if we want, but I'm going to really use the given angle so that I don't have any rounding errors. Of course, here it would not be an issue, but sometimes we get into rounding and that can distort our answers. It's always best to use the given information when possible. So I'm going to go ahead and find side B with the given angle 62.7 degrees and the known side of 8.4. That looks to be the trigonometric ratio not involving the hypotenuse, which would be tangent. So I am going to say the tangent of 62.7 degrees over 1 equals the opposite side of 8.4 over the adjacent side, which is B. And of course, I am going to solve that as a proportion, taking the cross products. And so B times the tangent of 62.7 degrees will have to equal 8.4. Which means to solve for B, I am going to have to take 8.4 and divide it by the tangent of 62.7 degrees. And that gives me a measure rounded to 2 decimal places of 4.34. So that's side B. That leaves me with only side C, which sometimes students will say use Pythagorean theorem. You could, once you know 2 of the 3 sides, or you could use right triangle trigonometry. I'm going to start with right triangle trigonometry, and as I look at the given side of 8.4, again, it's best to use the given information rather than the side we just approximated. So for my angle of 62.7 degrees and the given side of 8.4, C, of course, is the hypotenuse, and 8.4 is the side opposite my angle, so that would be the sine function. And I would say the sine of 62.7 degrees over 1 equals the opposite side, 8.4, over the hypotenuse, which is C. If I take the cross products, then that gives me C times the sine of 62.7 degrees equals 8.4. I will divide here to solve for C. C would equal 8.4 divided by the sine of 62.7 degrees, which with my calculator, make sure it's in degree mode, but I get about 9.45. At this point, we're actually finished solving the triangle because we have found the missing angle, B, we have found the missing side, B, and the missing side, C, and we now know all three pieces of information. As an alternative to what I just did with trig and the sine function, I could have used the Pythagorean theorem. Just as a reminder there, we know that a squared plus b squared equals c squared, where c, of course, is the hypotenuse or longest side, and in our case, that was the missing side. Side A was 8.4. Side B we found to be 4.34. But of course, that's a rounded value, so since it's rounded, we can sometimes lose precision. If we use a calculator, we get 70.56 plus 18.8356 equals c squared, and that means c squared is 89.3956, and by taking the square root of both sides, I can get the measure of c, and that is about 9.45. So it's the same answer we got earlier. It's just sometimes when you use rounded values and you use them in the next computation, you do lose accuracy. So you do want to be careful with that. So again, to solve a right triangle, you're doing what we did earlier in section 4.3. You're finding, though, not just one side or one angle, you're finding all the missing sides and missing angles. And in this case, we did not have to use an inverse trigonometric function, but in some cases, we might have to find an angle by using the inverse sine, cosine, or tangent. And that's where you press second and the trig function to find the angle that has the given trigonometric ratio. Also, in the assignment 4.8a in my math lab, there's a couple problems later in the assignment where the triangle is really a diagram that involves more than one right triangle. And you might have to use both right triangles to find measures that will lead you to the final measure they're asking you to find. So we're going to do one like that in class, but I just wanted to give you this one example, and hopefully that will help you. This is really a lot of review of what you've done earlier, but I thought seeing one example might help you. Have a great day.